Hello everyone, welcome back to my channel. Today I will demonstrate how to visualize word embeddings using PCA and t-SNE. Word embeddings represent words as numerical vectors and dimensionality reduction, which helps us to visualize these high-dimensional vectors into two dimensions. Okay, first today we will see this second A experiment. In this session we will see second A experiment of Gensim Lab. After that, we will see an second B of the Gensim Lab experiment. First, we will explain this program and then we will see some Viva questions which are most important for the lab exam, and then we will run this program and we will see the output how it comes. Okay. These are the libraries which we are importing. Gensim, import gensim.downloader as API, import NumPy as NP, import matplotlib.pyplot as PLT, from sklearn.decomposition import PCA, from sklearn.manifold import t-SNE. First, Gensim. Gensim, what it will do? Gensim, it will load the pre-trained word-to-vec model. Okay. Next, NumPy. NumPy, it will handle numerical arrays, vectors, and mathematical operations. All will be performed by the NumPy. I repeat, NumPy, it will handle the numerical arrays and vectors. Next comes Matplotlib. Matplotlib, it is used to create graphs and used to plot graphs. Matplotlib, it is used to handle the graphs or used to create the graphs. Next, PCA and t-SNE. PCA and t-SNE both are dimensionality reduction techniques. What it will do? Dimensionality reduction technique means it will reduce dimensions for visualization. Okay, but there are some differences between PCA and t-SNE. PCA, it is for dimensionality reduction purpose, whereas t-SNE, it is going to uh, group the clusters for better visualization. Next, word to word vectors is equals to api.load word to vec Google News 300. Here, this statement, it will load Google pre-trained word to vec model. Each word is represented by a three-dimensional vector. Each word is represented by three-dimensional vector, and similar words will have similar vector representation. Next, explore word relationships. Explore word relationship. In this, result vector is equals to word vectors of word 1 minus word vectors of word 2 plus word vectors of word 3. We have seen one example, right? Word 1 minus word 2 plus word 3. There we have used this example, right? King minus man plus woman in the first experiment of the lab, Gensim lab, right? There, in the same way, here it demonstrates semantic relationships. Semantic relationships means logically they are almost similar. The expected result is a word which is close to the semantic relationships. That is, if king minus man plus woman is equals to, the answer will be given as queen. Next, similar words is equals to word vectors dot similar by vector comma top n is equals to 10. It will find words whose vectors are closest to the calculated vector, and it will return the top 10 most similar words. It will return the top 10 similar words. So we have used top 10 is equals to 10. Next, filtered words is there. I will explain this program. Later we can learn some Viva questions and we will run the program. First, print statement is there. Word relationship word 1 minus word 2 plus word 3. Next, this is a scatter. We have used word to explore king, man, woman, and this and all plt.x label, plt.y label, component 1, component 2. For reducing three-dimensional vectors to two-dimensional vectors, we have only written component 1, component 2. I have left some PCA. This one, see, PCA visualization. This is called as PCA visualization. Why? Because reducer is equals to PCA of n components is equals to 2. That means it reduces 3 dimensions to 2 dimensions, where it preserves maximum variance in the data and it will make visualization possible. The main statement explanation for this one is it will reduce 3 dimensions to 2 dimensions, 300 dimensions to 2 dimensions. Next. Next is t-SNE visualization. t-SNE visualization. Yeah, here is t-SNE visualization. Yeah, t-SNE visualization, what it does, it is an dimensionality reduction technique only, but it will preserve local relationship between words. It will just preserve the local relationship between words and it produces meaningful clusters. I said cluster visualization. t-SNE it is used for cluster visualization and for better visualization, right? Next, here plt.scatter and plt.text. It is used for displaying words. plt.scatter it is used to display the words as points in the graph. You know, scatter it will display the words in points as, and this also helps us to understand semantic relationships which can be seen visually. And that's it, this experiment. It is very easy as the first experiment. And what is the output we are going to get in this? We'll check. Before that, we are going to learn some Viva questions, okay, which are important for the lab exam. First question is, what is word embedding? Word embedding. Word embedding is a technique that converts words into numerical vectors while preserving semantic meaning. Semantic means logically the relationships are similar. So word embedding is a technique. It converts words into numerical vectors. You can say just words into numerical vectors. That's enough for the word embedding. Word embedding. Word embedding, it is nothing but it will convert words into numerical vectors. Next, what is word to vec? Word to vec, it is a neural network based model, generates dense vector representation of words. That is all not needed. You can just say vector representation of words. Word to vec, it is used for the representation of words. Vector representation of words. That's it. Next, why do we use this word embedding? Word embedding we use for machine readable format. We use this for machine readable format. That's it. What is Gensim? You already know Gensim. It is a Python library. It is used for NLP, natural language processing, such as word to vec, top modeling. That's it. Word to vec, it is used for modeling. Word to vec, Gensim, it is used for word to vec modeling. It is a Python library. Next, what is the purpose of API load? Word to vec Google News 300. It loads Google's pre-trained word-to-vec model containing three-dimensional word vectors. In the statement itself, it is clear that it will loads API.load itself. It says it will load the Google pre-trained word-to-vec model, which is containing three-dimensional word vectors. What is vector arithmetic in word-to-vec? In previous experiment, we have seen vec1 minus vec2 plus vec3, right? In the same way, this is the example for that king minus man plus woman is equals to queen. That is the vector arithmetic operation. So now you can say this statement: mathematical operations which are performed on word vectors. Mathematical operations performed on word vectors called as vector arithmetic. So simple. Next, what is cosine similarity? Cosine similarity, it is nothing but a similarity between two vectors. You can go through this statement, but not necessary. This is simple enough to say for the Viva question. Similarity between two vectors is called as cosine similarity. Next, what does the similarity function do? Similarity function, what it does? It will just calculate similarity score between two words. That's it. Okay, before that we will run this program. Maybe it will take time. So we will run this and then we will go for next question. Next, we have learned this, right? Similarity function. It will just calculate the similarity score between two words. Next, what does similarity by vector do? It will return the words whose vectors are closest to the given vector. Similarity by vector, it will return words whose vectors are closest to the given vector. What is NumPy? What is NumPy? See, we have learned this, right? Oh no. NumPy, it is used for numerical operations. Oh, if we run that, it is giving problem here. What is NumPy used in this program? NumPy is used to store and manipulate word vectors efficiently. It is used to store and manipulate word vectors. Next, what is Matplotlib? It is used to plot the graphs. It is used to create graphs. This is the statement. What is Matplotlib? It is used to visualize word embeddings using graphs. What is PCA? Principal component analysis. Wait. Input Gensim downloader as API. It is not a problem. Still, it's giving error. That's okay. We will fix that. First, we will see what is Matplotlib. Matplotlib, it is used to visualize word embeddings using graphs. That means you can create a graphs by using a Matplotlib. Next, what is PCA? PCA stands for Principal Component Analysis. It is a dimensionality reduction technique. It is a dimensionality reduction technique. Reduce high dimensional data by preserving data set or information. Why do we use this PCA in this program? To reduce three-dimensional word vectors to two-dimensional dimensions for visualization, as we have discussed in this program, right? In the same way, three-dimensional word vectors will be reduced to two-dimensional for visualization. What is t-SNE? t-SNE stands for T-distributed stochastic neighbor embedding. It is a dimensionality reduction technique. Again, it is used for better visualization for high dimensional data or cluster. It is group cluster visualization. Next, what is the main difference between PCA and t-SNE? PCA, it is faster, whereas t-SNE, it is slower. PCA is faster, t-SNE is slower. PSNE, it preserves variance, whereas t-SNE, it preserves local structure. Okay. This I don't think this statements you will remember. Okay, only this PA is faster and linear technique is better. I think PCA, it is faster, whereas t-SNE, it is slower. PCA, it gives linear technique. It is a linear technique, whereas t-SNE, it is a non-linear technique. This you can remember, right? PCA, it is linear technique. t-SNE, it is non-linear. Faster, slower, linear, non-linear. That's it. Next, what is dimensionality reduction? Dimensionality reduction is the process of reducing the number of features while retaining important information. You can just say reducing the number of features. Dimensionality reduction means it will reduce the number of features by preserving some important information. Next, what is n components is equals to 2? As easy as it. It reduces data to two dimensions. It reduces data to two dimensions. That is called as n components is equal to 2. If 4 means it will reduce the data to 4 dimensions. That's it. What is the purpose of perplexity? Yeah, it's important question. What is perplexity can be asked. It controls how t-SNE balances local and global relationships among data points. What is perplexity here? It is it will control t-SNE how balances local and global relationships among data points. Next, what is NLP? NLP is it is a natural language processing branch of AI enables computers to understand and process human language. That's it. Easy, right? Enables computers to understand and process human language. What is word vectors? Numerical representation of words in a multi-dimensional space is called as word vectors. You can just say numerical representation of words is called as word vector. Next, what is the purpose of fit to transform? It learns the transformation and converts the data into reduced dimensions. It learns the transformation and converts the data into reduced dimensions. Fit to transform, this is also important. It will just transform the and converts data to reduced dimensions. And what is perplexity once again? Perplexity, it will control the t-SNE which balances local and global relationships among data points. Okay, thank you. I hope this session was useful. If any mistakes, please forgive. Bye. We will continue in the next session with the second B. In that session, I am going to um, show the output of this second A. Okay.